servo gyro data. Now you can see the benefit of having created that as a sub-typedef. If I make a decision later on that I want to add more data or more functionality to this servo gyro function that I'm using, then I just open its typedef, add a boolean, or anything for that matter, and say, for example, switched off. And when we put that inside our typedef, we apply changes and close it and save it. Then all of the instances of that typedef are automatically updated. So I know we have to do one more thing before we leave here, because we've only created one gyro. So I'm going to modify that to be tilt gyro type, and this rename it to be pan to keep them clear, and do the same for the servo. We've got our pan servo. We're going to make a duplicate of it, drag it right into the typedef, and call it the tilt servo. So now we know we have all the device references and the two data clusters within our robot data typedef. So now if I close this, save changes, I'm going to have to make a few minor modifications to use all this, but we'll get to that in a second. Before I forget, I want to go back to robot main, to the begin VI, and make sure that I open a gyro and a servo for my tilt. I drag this down to add my tilt device ref, make sure I select that. My tilt servo device ref, make sure I select that. And now I'm going to do some wiring. So I'm going to make a little bit more room, pull this down, pull these comments out of the way, and now practice those wiring techniques. So I'm going to take this gyro wire, connect it, and if I just go directly from here to here, you see that we have a wire that's rooted in a very useless location. And then if I were to repeat that with the servo, they're on top of each other, and it becomes impossible to debug. I'll undo both of those. So I'm going to start with the gyro with a single click, pin it down here, and here's an application where I want to use my spacebar, because the natural way that the branch wants to go is in this direction. But if I push the spacebar, then it flips the orientation of that branch, and I can put it exactly where I want it. And I repeat that with this servo open. So now we've made our modifications to our begin to add this stuff in. We can save, close this VI, go back to our teleop, and now what we wanted to do was modularize this code. So we already have pretty much all the functionality we want, except that we only have it working on the pan gyro, the pan servo, and the pan servo gyro data. So what we want to do is actually select all of this functionality and make a SubVI from it. We've talked before about how it's possible to create your own SubVIs. Now I'm going to demonstrate to you two different ways to do it. The first method is when you already have code in place. What you do is select exactly the code that you want to encapsulate, and from the Edit menu you choose Create SubVI. The benefit of this approach is that it takes everything that you wanted, including all the inputs, creates a SubVI for you. If we open this up, and if we take a look at the VI that's been automatically created, we see it is exactly the code we had before. And it has created controls in our front panel, which are actually linked up to the icon. We can see that by going back to teleop, activating our context help, remember Control H, and when we hover over the SubVI, we see that the various wires have automatically been connected, and they've even been named appropriately in the SubVI. And this is a great way to encapsulate code which already exists. Let me just undo that change. We won't save changes to that SubVI, to show you a second method of doing this. The second method involves creating a new VI from scratch and manually creating the inputs, the outputs, and linking them to the terminals of the icon. The manual method involves creating a new VI, placing the inputs and outputs manually, and also linking them up manually to the icon. It's important to know how to do this, so let's do that method next. So we're going to choose to create a new VI, and on this VI I'm going to place the inputs that I know that I want. So let's begin actually by going into the robot data typedef. I'm going to open that typedef, and I'm just going to copy the controls that I want. I want my servo reference, I want my pan servo data, and I want my gyro reference. Just going to copy those, close the typedef, and return to that SubVI. Next, I'm going to paste those on the front panel. And I'm just going to change their names. Because remember what we're doing here. We're not creating a SubVI for the pan, nor are we creating a SubVI for the tilt. We're creating a SubVI that we want to use for both situations. So I'm going to make the control names more generic and remove the pan. So I've got my gyro reference in, my servo reference in, and my servo gyro data. I'm going to just clarify that that's an input. And I'm going to make a duplicate of this using the control key and call it servo gyro data out. And make sure that because it's an output, I right-click on the very edge of the cluster and choose to change it to indicator. So now I've created all of the inputs and the output. If I look at my block diagram, I see I've got my terminals, but I don't have any code yet. So I'm going to have to copy and paste the code from the main program. However, before I do that, we need to link up these inputs and outputs so that the teleop VI knows how to communicate with this SubVI. If we go to the icon, we right-click on it, and we choose Show Connector. We see that we are presented with this particular pattern. We can change the pattern by right-clicking, going to the Pattern submenu, and see that we have all these different choices. Basically, if you have a lot of inputs and outputs, you need something with a lot of terminals. If you just have a few, then you can use one of the patterns with fewer terminals. It's a really good idea to pick a particular terminal pattern and stick with it. And the default one is probably the most commonly used one. Because if your terminal pattern is always the same, you can be consistent in where you wire your inputs and your outputs, and it becomes very easy to chain together multiple SubVIs. Okay, so let's link these up, and the way we do that is we click once in the desired terminal spot with the wiring tool, and then we click once on the desired control. And now, because the terminal has turned to a different color, we know that that's been properly linked up. So we repeat that process, next to connect the servo device ref, and finally to connect the servo data. And it's good practice to connect the data input and the data output in the same location but on opposite sides of the icon, so that, again, it's easy to chain things up. And next we can create an icon by right-clicking and choosing Edit Icon, and this is where you can be as creative as you want to be. One of the shortcuts I always like to use is to change the background color, leave the foreground color black, and then double-click on the filled rectangle, which will give you a colored background, and then choose the text tool and just simply type something in. Another nice hint is that if you double-click on the A icon, you can choose the font that it's going to use. If you choose small fonts size 8, that will give you at least a few lines of text. So you could call this the gyro servo SubVI. Another nice hint is that you can move this text around using the arrow keys as long as you haven't pinned it down by clicking off with a different tool. So it makes it very easy to create quick, informative, although not necessarily pretty icons. Next, we're going to save this SubVI. This is probably a good time to suggest that you create a new folder within your robot project and call it Team SubVIs. It just makes it simpler to maintain and keep track of all these things if they're not all sitting in one directory. And again, we're going to call this the gyro servo SubVI. Okay, so we've created our SubVI, we've created our inputs, our output, we've created our icon, we've linked up all the terminals to our pattern. We've done everything except actually create some code here. So let's do that now. We're going to return to the teleop VI and just copy the code that we know already exists. We're going to steal this code, we're going to just reuse it. Then go back to our gyro servo SubVI, block diagram, just paste this down. So now what we need to do is just hook everything up. So we've got our gyro device ref, which we know has to go in here. We've got our servo device ref, which we know has to get connected to the servo SubVI. And we've got our servo gyro data in. Well, we know this is a cluster, and if we return to the front panel for a second, we take a look. So we've got our switch off time, which we know we're going to use. We've got a couple other spots here containing the gyro read angle, the servo set angle, and a boolean for switched off.